Practice Exam 2, Part 6. Okay, we're on the proof sections finally. We're starting with number 11 here. 11, yeah. Okay, so we've got these two premises and the conclusion. As always, you've got to present it with it like this. Right, just the dash with the conclusion. You've got to write the vertical line, put the conclusion down the bottom. Okay, hope you know how to do that. All right, you should remain conclusion driven. You should look at your conclusion, ask what it is, what its major operator is. It's a conjunction, and ask yourself, what rules allow me to derive formulas of that form? So in this case, what rules allow you to derive conjunctions? Well, it's the rule of conj is the most pertinent one, right? You're probably going to get this by deriving not B separately, and then C hook not D on the other side, and then putting them together by conj, right? Then you'd have the premises of conjunction, P, premise 1, Q, 2. So you could infer the conclusion, P and Q, by conj, right? Let's notice something else about the conclusion. Okay, you've got not B, you've got a C, and a not D. Okay, not B, okay, look at the premises. There's a very obvious modus ponens waiting to happen, right? So let me just go ahead and do that, right? Not B or C. I've derived the smiley face emoticon. 1, 2, modus ponens. And I'll be able to get my not B easy enough because that's the, why is it the smiley face emoticon? Why a negated disjunction smiley face emoticons? Because I do De Morgans on them. Something around there. De Morgans on 3, which leads me to a conjunction. Conjunctions I simplify. Right, so this is just me doing some obvious moves, right? Top-down reasoning. For simp, right? So I've derived, you'll notice, I did the modus ponens, and as I sort of suspected, that allowed me to get the not B. So I've got one of the two conjuncts I need for my conclusion. But let me go back to being conclusion driven. My other conjunct is what? C hook not D, right? When you're remaining conclusion driven, you look at your formulas and you say, what rule is going to allow me to derive them, and where is it going to come from the premises, right? Where does a certain formula, plus or minus a negation, appear amongst the premises? Okay, so I've got a not C, right? So there is a C, plus or minus a negation amongst the premises. But there's a not D in my conclusion. What do I notice about the premises? If I search for a D, there isn't any, right? There's no D's here. Which sort of alerts me to the fact that I'm going to have to pull D out of thin air, right? Which means I'm probably going to have to use an add trick, right? So remember the add tricks, and especially remember, here you will have to apply one of the proof bits, which we spent a lot of time on, what's the coordinate, from Unit 8. Okay, you remember the proof bits? And what did I say about those proof bits from Unit 8? You have to be aware that certain paths exist, right? From, for example, if you need to derive a negated conjunction, there is a path, proof bit, from the negation of one of the disjuncts to the negated disjunction, right? So, right, there is a proof bit that goes from not P to not brackets P and Q. Right? And in each case in the case of each of those proof bits, you need to know that that path exists, most importantly, so that you can be aware that you can make the moves necessary to get from here to here, if your proof requires you to do so. And secondly, of course, you need to know what that path is. You need to know that the proof bit exists and how the proof bit goes, how the proof goes. It's a proof bit because, as Klenk explains in Chapter 8, it's like a subroutine that you'll pull out in the middle of the proof to get you from where you are to where you need to be. Okay, well, you need one of them here, right? Specifically, what do I need to get to? I've got one of the conjuncts, so I'm home free, as it were, if I can somehow derive C hook not D, right? But not B by itself. I don't know where I'm going to get this yet. How am I going to get C and not D? sorry, C hook, not D. How do I get that? I don't know, but I'm just thinking backwards and thinking, right, I just need to get this second disjunct and I'm home free. Then I'll have the two conjuncts and I can put them together by conj. How do I get this? Here is where you have to become aware that the path from specifically not C to C hook not D is the application of a proof bit. I think it's proof bit number 2, I think. Because what you have here is an instance of not P going to P hook Q. The first 2 proof bits from Unit 8 were deriving conditionals, right? And as I recommended then, you should learn to speak or say those proof bits in words such that you're grasping them formally, such that you will see them in complex applications like this, where things are not in terms of P's and Q's, but complex formulas. So the first 2 proof bits were, you are entitled, in words now, I'm grasping it formally, you are entitled to derive a conditional if you have the negation of the antecedent. Right, so this is negation. The other one was if you have the consequent, right? So the other one was from Q to P hook Q. If you have the consequent, you are entitled to derive the conditional. Yeah, right. If you think of these formulas semantically, if you think of the formulas involved in these proof bits semantically, you should be able to convince yourself that such a proof bit should exist. Just think, by think semantically, I mean think in terms of truth conditions. Think of what it is, what are the conditions under which formulas are true and false. When is a conditional true? Right? A conditional is true, just think back to the truth table for conditionals. It's true when either the antecedent is false or the consequent is true, right? And that's those 2 proof bits that we're talking about. The first is the antecedent of this conditional is false. That suffices for the truth of the conditional. So what should this convince you of? This should convince you of the fact that this is a valid inference. The path from here to here is truth preserving. If this is true, for certain, this is true. If the antecedent of a conditional is true, the conditional is definitely true, just by the truth table for the hook. Similarly, if the consequent is true, that suffices for the truth of the conditional, thus there should be a proof bit, should be a path from Q to P hook Q. Okay? So that's what you have to recognize here. You have to recognize that this is an instance of this, right? What I've been saying for proofs, it's all about learning to recognize the forms in complex instances, right? You have to see that this is, right? If you thought backwards, you realize you're home free if you get the second conjunct, right? And so you have to see in the fact that you've got this and that you need to get from this, in this path, that this is a not P to P hook Q, right? It's exactly this, right? You have to realize that this is, well, you have to be able to, if you could say formally what you need, you might recognize, if you comprehend the proof bit formally, you will recognize that what you need is precisely that proof bit, right? I need a conditional. What do I have? I have the negation of the antecedent of that conditional. Right? What knowledge do I have with regard to the parts of this conditional? I need this conditional. I have the negation of the antecedent of the conditional. Oh, wait a minute, there's a proof bit such that given the negation of the antecedent, I can derive a conditional. A proof bit exists. I know I can get from here to there. Okay, what is it? Remember, right? Thinking this backwards, do a conditional exchange on this in order to get the formula in terms of a disjunction, because basically all these proof bits require an addition trick, that is adding something, right? How am I going to get this Q, whether there's no Q up here, you're going to add it. That's how you get no formulas, right? Add is the rule. Given P, you're allowed to infer P or Q, right? Or given Q, you're allowed to infer P or Q. That's the rule of add. It's a rule of inference. All right, so when I have that, I'm going to derive that by conditional exchange, right? And now this is a disjunction. Disjunctions are the conclusions of adds, of the rule add. That's why I need this junction. So how do you get from not P to P or Q? It's add 1, conditional exchange 2. Okay, so we're applying that proof bit here. Okay, so what is it? Step 7. I'm thinking this backwards, to be honest. By conditional exchange, not C or not D, right?
Dad?
So if I have that, then
Dad,
make
which boat do you like better?
this one. Conditional exchange, right? So how did I get from 6 to 7? Right, that was the add. 6, add, right? So that's 7, and then 8. C hook not D, conditional exchange on 7, boom. My conclusion is now obtained by conj on 5 and 8. See that? Yeah. All right, and that is the proof for number 11.